All right, so 9.1 was using the probability formula on events that were easy to count. So 9.2, we start getting into things where it may not be as easy to count, or it might be complicated. So we just need to learn counting rules that we can apply to the probability formula. For example, like if you flip a coin 3 times, how many outcomes can there be? Right, what are all the outcomes? So what you do is draw a tree, basically. So let's say I flip a coin. So the first event can either be heads, right? Or tails. If I assume that the first event was heads, then I can then get another heads or a tails. If I assume it was heads, the next event could either be a heads again or a tails. See how it branches off? If I assume that there was heads and then tails, after that I could get a heads or a tails. If I assume it was heads, then tails, they could be heads or tails. If I assume it was heads, it could be heads or a tails. If I started with tails, then I could get a heads, then a tails. This could be heads or tails. And then this could be heads, then tails. Sorry, my drawing's a little crappy there, but as you can see, the way I want you to think about this is each time I flip the coin, there can be 2 outcomes, right? So the number of outcomes in S is actually equal to 2 for the first flip times 2 for the second flip times 2 for the third flip. So there's 8 total outcomes, which we can count right here, right? S would be, could be heads, 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 tails. So that's this branch and that branch. Then we could have heads, tails, heads, or heads, tails, tails. Right, that's these branches right here. Heads, tails, heads, heads, tails, tails. Then I have to go to this branch. So if I assume it's tails first, it could be heads, heads, right? That's the first branch. Or it could be tails, heads, tails. Or it could be tails, 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 heads, or just tails, tails, tails. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. So we can count the events this way. You can also draw them out and figure out how many or what they are exactly. Okay. And you can do that with anything that has multiple outcomes. But the more times you flip, the more trials that you have. These trees, you start to branch out pretty quick. Okay. Let's see if I can find an example. But anyway, so this was the multiplication rule right here. This is the tree. Okay, let me give you the formal definition. Just a moment. And we'll apply it to something else. Okay, here's the multiplication rule. So if an operation consists of k steps, and the first step can be performed in n1 ways, second step is n2 ways, all the way until I should say nk right there, nk ways. Then all you have to do is multiply the number of ways together, and then you'll have the entire operation. So just like we did the first example, if the first flip has 2 ways, second flip has 2 ways, third flip has 2 ways, then the total number of ways you can flip 3 coins is the multiplication. So all you have to do is multiply, and you'll find the total number of ways. Let's find an example. So here's a good example for multiplication rule. So how many ways can I order dinner if I have 5 entrees, 7 sides, and 2 desserts? Let's assume that we're going to only pick one from each menu item, right? So 1 entree, 1 side, 1 dessert. So since you know how many ways how many entrees there are, how many sides there are, how many desserts there are, the total number would be, the answer would be 5 times 7 times 2. So this is the total number of ways that you can order dinner. So 5 times 7 is 35 times 2, 70 ways. So this is in essence, the multiplication rule. So if you know how many ways the event 1 can happen, event 2 can happen, event 3 can happen, the total would be the multiplication. Okay, let's talk about permutations. That's another way to count things, or a way of counting. So a permutation of a set of objects is an ordering of objects in a row. For example, ABC can be rewritten as ABC, ACB, CBA, BAC, and CAB. So when you're doing permutation, order matters. So for something like a password or order would be important. So that would be considered a permutation. Some counting techniques consider ABC and ACB to be the same element. That would be more of a combination, but we'll talk about that later. For any integer n, when n is greater than 1, the number of permutations of the set with n elements is n factorial. So basically, if I have, let's say, 4 items, and I ask you, how many ways can I shuffle these 4 things all at once? Well, that would be 4 factorial. Okay, I don't remember if we've talked about factorial, but factorial means, right, 4 times 3 times 2 times 1. So the total ways would be 24. Right? 4 times 3 is 12, times 2 is 24, times 1. So if I have 4 objects, 24 ways to shuffle them. Over here I had 3 factorial, right, would be 3 times 2 times 1, which is 6 ways. 1, 2, 3, 4, 5. That was 6, actually. Missing 1. BCA is not in there. 6. Anyway, so I'll say it's easy to count them if you're taking them all at a time. Okay, so that's what the permutation of n items works. Is how it works. For example, let's do an example here. How many ways can I arrange the letters in, let's do part A, the word computer. Okay, well, that would be 1, 2, 3, 4, 5, 6, 7, 8. So this would be 8 factorial, which would be 8 times 7 times 6 times 5 times 4, all the way down to 1, which would be 40,320. Now, if they were to group computer, the word CO or the letter CO as one item, let's say they said, you know what, you cannot separate in computer but keep CO together. All right, so consider CO as a unit. So this is like one element, one letter, kind of. So basically all you have to do is use 7 factorial because we're shuffling this as its own element. So picture it like this, I guess. CO M P U T E R. So 1, 2, 3, 4, 5, 6, 7. So the answer would be 7 factorial. So that's about 5,040 ways. Okay. All right. So here's the formula for permutations. So if you have n, number one, R is always less than n, and they're both always 1 or greater. Okay. So n is the total number of items, and you choose R at a time to shuffle. So the question becomes, how many ways can I shuffle 5 objects if I take 2 at a time? So that'll be our first example. That's what this does. And it assumes that order is important because it is a permutation. Round number 4. Okay. So suppose we have 5 books on a shelf. And I want to rearrange them 2 at a time. Right, so part A, how many ways can this be done? So what you do is you take the permutation formula and say there's 5 total numbers, choosing 2 at a time. Okay, so n is 5 factorial, so 5 for n over 5 minus 2. So that simply becomes 5 factorial over 3 factorial. Find out how many ways that is, and let me show you a trick on how to reduce factorials. So what you can do is go all the way until 3 and stop, because technically 5 factorial goes all the way until 1. And then you can just cancel these guys here. If you wanted to, you could expand all the way. But you can see that if I had like 17 factorial, that this would be kind of lame. So just cancel, just stop at the factorial you want and then cancel them. Anyway, there's 20 ways that I can rearrange 5 books, choosing 2 at a time. So that's all you have to do. Let me show you how to do it on the calculator as well. If you have a TI 30 or 34, that's pretty easy. If you want me to show you on one of the other ones, I'll show you the calculators. But here's the popular 84, 83. It's a little bright. Okay. So you hit the math button. It's a little bright here, so I can turn the light on. That's better. Hit math and then go to probability, and then choose NPR. So NPR requests a number 5 and a total number n, and then the number you selected for R. So 20. So it turns out to be the same thing. is how I do it by hand, and this is how you can also do it with any scientific calculator. All right, let's do one more. The word bytes. How many ways can 3 letters of the word byte word bytes be chosen and written in a row, right? So basically total letters 1, 2, 3, 4, 5, right? So n is 5, and I'm choosing 3 at a time. So you would do 5p3, when the formula would say 5 factorial over and then n minus r is on the bottom, so that'll be let me show you the total formula, actually, it'll be better. So that'll be n factorial over n minus r factorial. So that'll be 5 factorial over 5 minus 3 factorial, which is 5 over 2 factorial. We'll just do what we did last time. Stop at 2, 4, 3, 2. And there we go. So we can arrange the 3 letters in the word bytes. So basically taking 3 at a time. The total number will be 5 times 4 is 20 times 3 is 60. Anyway, so that's how permutation works. So whenever order is important, use this formula. If you take all the items at once, then just do n factorial.